So today's review video is a little different. As you can see, I've already worked these out. So I'm just going to talk about each problem and help you see maybe how I worked the problems out and their answers. Questions 1 and 2 are set up very similarly. Both of these ask you to solve for the value of x. So to do that, we generally make a table. Remember, they give me the starting value. So if my starting value is 2, I put 0 and 2 in my table together. And then my pattern is 3, which means I'm going to be multiplying by 3. So the goal then is just to figure out where is my target number. So this number out here is going to be my target. And I just continued my table until I found it, which was at the 4th spot. You can make this table in your calculator. You can make your calculator do it for you. But on your test, I'll probably ask that you write the table out. But that will be given in the directions. Similarly, on 2, 4 is my starting value, and then 1/2 is the pattern. Remember, because it's a fraction, that means to divide by 2. So I'm just going to do that over and over until I hit my target number of 1/2, which happens at 3, so x equals 3. All right, in question 3, I know that this is going to be an exponential equation because I've got a percentage in it. So the things I notice, it tells me the initial value is 23,000. It is decreasing, so I'm going to do 1 minus in my equation. And then 8%, remember you got to move that decimal 2 times, which is how I got the 0.08 here. And then it says to the nearest tenth, when will the value of the car reach 10,000? So to the nearest tenth tells you need to change your calculator in the table settings so that it counts by decimals. And then you're just going to look in the table for when does it hit 10,000. And in my calculator, that happened at 10 years. If you need help with your calculator, you may need to put a little star and say calculator so we can talk about that tomorrow. Okay, here's question 4, very similar. They give me a starting value of 6,500, so that goes in my equation. Increasing, so I did 1 plus 4%, moved the decimal 2 times and got 0.04. And then when will it be 4 years? So you have 2 options. You can look in the table for 4, or if you don't like using the table, you can take this number and plug that in for x, since we would be looking for that 4 in the x spot anyway. And when I plugged that in, and just to calculate, not in y equals, but just in the regular calculator part, I got 7,604 and 8 cents. All right, this question is similar to some of those that we did last week, kind of thinking about the graph. So they give me a starting point of 3. I see that, and then I also see a pattern of multiplying by 2. So I'm just looking through my equations to see which one gives me that. The only other question that has a pattern of 2 is A. All right, this one has a pattern of 3. That one has a pattern of 3.3, so I know it's not either of those. And since it's starting at 3 and not 1.3 like it says in A, the correct answer would be D. And so that explanation is the same thing you're going to use for question 6. I'm sorry, not for question 6, but just for the rest of that, explain your choice. All right, question 6 gives us 2 options. So for A, I think you all are okay with the starting point. The only thing that you may need to make a note of for yourself, is how to change this over. So 1.5%, even though it's a decimal, right, like you see the decimal, you still have to move it 2 times, which is why this number becomes 0.015 when you put it into your equation. So even though there's a decimal there to begin with, you still have to move it because it has a percent sign. All right, and then part B here, because this is not got a percent and we're spending 40, 40 is going to be a constant rate, which means I'm going to write a linear equation. And then spending means we're going to decrease the amount. So I'm starting with 500 and I'm decreasing $40 each month, which means this right here is a rate, 40x. Okay, the biggest thing you need to know on 7 is that exponential is the same thing as geometric, which means I'm looking for a pattern of multiplication or division. So when I look at these, that's kind of what I'm really only looking in the Y column. That's the only part that you're going to care about there, are these patterns of multiplication or division. So when you look through the Ys, B and D are the only ones that appear to be patterns of either one of those. C, you can't divide by the same thing every time. And the same issue with A, so both of those are no. Question 8 is very similar. Linear, so you probably need to write this down. Linear should make you think arithmetic. And arithmetic is, we're looking for a pattern of addition and subtraction. So this pattern of addition and subtraction, you're wanting the exact same thing every time. And again, we're only concerned about the Y values. So make sure you only look at the Y values. All right, you may not have been as much of a fan of question 9 because of the decimals, but that's okay. So here, remember 1/4 is your starting place. So at 0, I put 1/4. And multiply by 3 is your pattern. So to go forward, just remember you have to multiply by 3, and then to go backwards, I would be dividing by 3. And then all I did for part B was I took those values that would fit okay, and I put them on the graph. So the ones that I have graphed are 0 and 1/4, that's like 0 and 0.25, 1 and 0.75, 2 and 2.5. All right, so I'll show you, those are the ones that I've graphed. And then I also kind of tried to graph that one, and I just said, okay, that's really close to 0, but not quite there. So that's how I got the graph part for that. I think if you all had better numbers, you might feel more confident about that if you're not so sure right now. Okay, just check that you made sure you wrote your equations correctly for account A and for account B. Remember that in linear, your rate, each year, your rate is the one that needs to have the x with it. So it needs to be 40x, not 200x. And then the question says how much more. So we know that it's going to be more at B, and it's not asking how much it is at plan B, it's asking how much more. So plan A gave me 600, plan B gave me 809. So to find how much more, it really means I need to subtract those two to get the answer of 209, because it's 209 more dollars with plan B than plan A. So that's how much better it is, not just that it is better in the long run. Okay, so similar to the ones we've done before, remember this says, this says decreasing, so we need to be subtracting. And then also, this is saying in 5 years. So similarly to maybe question 4 on the front, I can't quite remember the number, you can use a table, or you can plug 5 in for your exponent and just type this in the regular part of your calculator. And I actually disagree with my answer here because it would be sad to find 0.41 of a deer. So instead, I want to say the better answer here is that there were 887 deer, right? We should not produce part of a deer. That would be sad. Here, the starting value, I think you all are okay with both of those. A is growth because it starts with a 1. B is decay because it's starting with a 0, so it's less than 1. And to find those decay rates or growth rates, you can do 1 minus the number that you're given. So that gives me, and I'm going to ignore the negative sign, 0.035. And then I have to move the decimal back 2 places to where it would have started, because this is like asking what the question would have been beforehand, which is how I ended up with 3.5%. Here on B, I did the same thing, 1 minus 0.94, and I got 0.06, and again, move the decimal 2 places back to where it would have started, which would have made it the whole number 6 in the end. And lastly, question 14 we talked about in class today. Just remember that because this one was $200 a month, we had to multiply that by 12 so that we could get $2,000, so we could get $24,000 in our equation. Everything else I think that you all are okay with. Do make sure that in part B that your X is with the 500, because the 500 is the rate, right? The starting value is on its own, but the variable goes with the rate. And then part C, I did that using my calculator, and all I did was I put the two equations in so that I had like A and B, and then these are my X values, 1, 2, 3, and I'm just looking, it says, after how many years will they have a greater salary at job A? So you're looking for when does A get bigger? And it should be that you find somewhere around 6 years, it turns that A is bigger out than B.